Greetings all. Here's a review of the standards meeting from the 6th of June. This is the P1954 meeting. We had 3 attendees, and there was a call to order. Then there was a roll call of individuals and a declaration of affiliation. We went over IEEE's patent policy and the copyright policy because it's very important to know what information that goes into the standard might be subject to copyrights or patents, and to work that out as it's being introduced. The declarations of affiliation are just like, who are you working for? Who are you affiliated with? Who are you representing on the working group? And all of this is very standard for working groups. We went ahead and approved the agenda without any difficulties. There were no minutes from the previous meeting. The previous meeting that we've had was a recruitment and sort of touch base, meet and greet, and went over some of the same issues with both policies and encouraged everybody to reach out and to recruit more members for this working group. So the agenda went on. There was an update on current activities, a discussion about requirements, and then a discussion of what the next steps would be. And then they opened the floor for any other business and then adjourned. So what I did is the slides that seemed most important, which was almost all of the brief slide deck, I went ahead and reproduced here. So there's the slide that explains, like, as participants, what we have to be responsible for in terms of informing the host organization for this standards group, what we have to tell the IEEE. The standard is intended to be open, so dealing with any potential claims is important. There's a code of conduct from IEEE was mentioned as well. There's a copyright policy. So getting permission to use copyright material in the standard is important. So it's not that these things can't be used. It just the rights need to be managed correctly. The principles for P1954 are here on this slide. So it's Fabrizio Granelli from the University of Trento in Italy, the vice chair, Anand Mukherjee, a research associate at the University of Cambridge in the UK, and then the secretary, Xiangping Liu, a PhD student at Monash University in Australia. So quite the international crew. The agenda, no objections, no comments, was approved. There was an introduction of task group reports and presentations. So sort of a state-of-the-art task group. Their goal was to write a white paper on the existing solutions within the scope of the standard, and requirements and scenario task group to define the set of requirements. So we have to start with requirements. That's really kind of a very standard approach to writing any sort of standard or specification, is that what are the requirements, and that work has begun and was, really this meeting was the first chance to start talking about these, all of the issues and all the potential requirements. So you can see there's some papers that are involved here. There's a communications society paper, and then channel models. So knowing what your signals are going to be dealing with, and the frequencies and use cases of interest is very important. And so we dove right into the discussion about requirements. So this working group is the standard for self-organizing spectrum agile unmanned aerial vehicle communications. And this particular working document is the use case scenarios and requirements. This working document has been shared, or has been shared with the participants. What they're using is Google Drive to share documents and artifacts of the meetings, like things like slide decks. So the person doing the channel modeling is doing this with ray tracing using a tool called Insight. The outdoor environment up to 1 kilometer altitude at different distances, generally urban, is what they're looking at first, with the density of structures and the compositions of structures being varied. And the results show that a free space model is not valid. Can't just assume free space just because you're high up in the air. There is multipath observed in the channel model when you use this tool and when you set up the environment for urban with a variety of structures. So this does conflict with some advice we previously got, but I think we need to see what the author, Kamesh, has simulated to see just how much multipath the channel model predicts. If it's relatively small, can be handled by standard techniques, then um, we know what to do. And another item of interest, this channel model was from 1 to 3 gigahertz. This doesn't include 5 gigahertz or 900 megahertz. The lower frequencies are generally required for the longer ranges. Um, and anything above 2 kilometers for this group is what they think of as long range. And the higher frequencies will give you higher data rates, but there's some directionality. So on Slack, I just reproduced the slides where the working document was being shared. There's a number of use cases, and they were pretty interesting. It's a broad enough set of use cases to give us a good thing. The Q&A for this was interesting. There was a question that came up pretty early on in the use case list about backhaul. So there's an assumption that there's going to be a bunch of drones. They're going to talk to each other. They're going to do some tasks, and they self-organize, and they're agile, spectral agility. They do interesting things. But all that data, especially video, has to go somewhere. It's going to be consumed by ground station, and that's the backhaul, and then maybe off to the internet. And there was a question in here about some of the language which made it look like to the questioner that we were going to make like some sort of backhaul API and not just stick to the drone to drone communications. So that got talked about for several minutes. The information exchange among the drones, they need to do something with the backhaul. That part needs to be addressed, but we don't have any authority to like dictate what the backhaul looks like. So I think that got it sounded like it did get worked out. People understand. We are going to have to list like talk about backhaul and uh, requirements for that in here. So the concern was, we don't have any, we don't want to mess with anything. We don't want to make something custom. We don't want to cause more work than we already have. And then something that Anshul picked up on is going to work with Kamesh about is beamforming and creating a line of sight from a drone, especially at higher frequencies. They're talking about beamforming. You really do need some directionality in order to get the gain required to close links and to maintain, enough um, signal strength in order to do the things that we want to do. So I'm looking forward to hearing what Anshul has about that. And then there was a discussion about whether or not this 50 megabit per second number was sufficient. If we're gonna pick a number and put it in a specification, then it's going to have to be sufficient for all the use cases. So lots of chicken and egg issues with frequency and spectral agility. And there was power consumption, sustainability of networks, adaptive data rates, some good stuff. At the time of the meeting, that working document had not been distributed on the mailing list or had yet shown up in the folders. So we tracked down that yeah, we're supposed to get this meeting. And that was it. So that was the big activity for the past week, was to see these use cases and to meet a number of people. Nearly 20 people were on the call. The vast majority were academics from universities all over the place that were actively researching drone communications, especially swarm and frequency, self-healing networks, frequency agile networks, the sorts of things that the standard addresses. There was relatively few industry people. Just by listening closely to the affiliations, I think there was at least one, maybe two, and then the three participants from ORI are open source representatives. So I'm very curious next month when we have our next meeting to see which directions we go in and how we can, continue to positively influence the group to choose open source friendly techniques. The I think the biggest battle has already been essentially won. That this standard is going to be an open standard. That's already decided. So it's very nice to not have to battle that. And then what we can look at from here is where we can step in and say here's a open source friendly or open source preferred solution to these sorts of problems. And then the benefit that we get out of this is learning an awful lot about use cases and technologies and uh, potential requirements, specifications that can inform us in our work to make Neptune better. All right, so that was what we did over the past week. The plans for the next week are to continue to work in the lab in order to get a modular communication system up and running at 5 gigahertz for priority video content. This is a physical layer link that we're looking at. We did spend some time looking at Veilid, which is or spelled Veilid or Veilid, and this was a networked application framework that I thought maybe this would help. So a peer-to-peer network, secure. It looks like it's a little too top heavy. This kind of assumes that it's running over traditional internet, and the approach may not be great for drone communications. But some of the things with this project were, definitely worth looking at, and none of us regretted digging into this. So probably not feasible to like use this framework as is on Neptune or some other project. But if you are looking for networked application frameworks that fill a gap that address particular needs and are secure, then Veilid is worth a look. And yeah, I think that's it. And that brings us to now. And we'll please check in on Slack and see what's going on, what's happened, and pitch in if you can on the HDL blocks that we're working on in order to make Neptune work over the air and do some demos. All right, thanks everybody.
boy, ready